Hi everyone. All right, here's the 6-2 um plane curves. I had a little in there, not starting out too well right now. Plane curves and parametric equations. So we had previously talked about um polar and rectangular coordinates converting back and forth. So the second part of this section is the plane curves and parametric equations. So for this, um you need to get in the mindset that um, we're going to have a curve path where a point is essentially moving along that path. Um, and your x and y coordinates are going to be functions of that. So they're going to be functions of time. So for this section, for parametric equations and plane curves, your x coordinates that you're going to find are functions of that time. So there's one function of time, and your y coordinate is a second function of that time. So we have f of t for our x coordinates, and we have g of t for our y coordinates. So these functions are going to help us plot points. Okay, that's as basic as I can make that. So these functions for x and y, so that's your x coordinates, those are your y coordinates. Those functions are going to give us points to plot. Okay, and that's parametric equations. So we're trying to find a parameter, a range of values for that. So this example right here hopefully will help explain that a little bit more. So for x, we have this function t squared minus 3t. For y, we have this function t minus 1. Okay, and we're going to look at the range when t is -2 all the way to 5. And we have a chart right here that is set up nice enough for us that we can find our values in that range and we'll plot our points. So just like any other function before, you're going to take your inputs. Okay, you're going to take these inputs and you're going to plug them in wherever there is a t for both x and y. Okay, so what I'm saying is for x, for -2, x equals -2 whole thing squared minus 3 times -2, and then we're going to get a value for x. So that's 4 plus 6, we should get 10. So we're going to do that for all of our x values that we need to find and all of our y values. And we're using just this range of -2 to +5. That's the only thing we're really going to look at right now for those. So again, for x, we're going to take -1. That's our next t value. And we're going to plug it in and get our coordinate. So we have 1 plus 4, not 4, Mrs. Conine, it's 3, and you get 4. It wouldn't be class if I didn't make little mistakes like that, huh? So then we have x, we plug in our t value of 0, and you should just get 0 there, and you're going to do that for all of these numbers. Okay, you're literally taking the value of t and plugging it in for each part in the equation. So plugging in 1, so this is now 1, not t, goodness gracious, 1 minus 3, you should get -2. And you're going to do that for each of them. Okay, so you need to take the time right now and do that. You can use your calculator for that. I did put a link for a calculator for your Chromebook. It's an add-on for Chrome. Make sure you get on there and do that. And then you have a calculator. So for the rest of the values, you should have -2, 0, 4, and 10. So if you look, it's symmetrical, and it really should be because this is a quadratic. So if you remember from quadratics, there's a symmetrical. It's not going to look like a quadratic right away. So keep that in mind how we're going to set this up. It's not going to be a quadratic, but the characteristics are very similar. So now we're going to do the same process for y. Okay, we're going to take these t values and we're going to plug them in for our y function. So y is going to equal -2 minus 1. So that should give me a -3. And again, you're doing this for all your t values. So y equals -1 minus 1. We should get -2. Okay, so you can do those values. That's the algebra part that I know you can do. So we have -1. You should get 0, 1, 2, 3, and 4. All right, so I'm going to move this over really quick. Okay, move that over really quick because that's all of our x information. I don't want to delete it, but I do want to show you how we're going to graph this information. So we have all of these numbers for x, okay, and we have all of these numbers for y. These are all xy coordinates now. Okay, so from the box up here, your function in the x spot and your function in the y spot give you coordinates. So we're going to use these numbers that we found and we're going to plot points. Okay, so we're going to take what we can and plot them. So I think 10 is a little too far, but we're going to do 1, 2, 3, 4, -2, 0, -1, -2, 0, -2, 1, 0, 2, 4, +3, and again 10 is a little out here, so our function will continue past what we're going to graph. Okay, we're just looking at this specific range. It will go on for forever and ever, but we're only looking at this specific range of values. So we're going to go ahead and connect our dots. Okay, it's going to go on and on forever. We're not going to put arrows in there quite yet because I want you to see we do have this shape on our graph. Okay, so we need to think of our graphs as time and motion and something that's continually moving. So this graph represents a point that is moving, that is moving. Okay, so we're going to write arrows on here to represent the motion. So we started at -2 for t, and that's where we can, I'll guesstimate, let's say like 10, -3 is out here somewhere, and 10, +4 is up here somewhere. So we started at -2. Okay, so we started around here when we get our 10, -3. So our point is going to continue through that path because the next point that we hit is when t is -1, so 4, 2. And we continue on that path of that moving, of that time. So the motion of the point comes from this direction, moves through my function, curves around and goes back this way. Okay, so we need to use the purple arrows to represent that motion, that time that's happening. Okay, because t started with the negative numbers right here, that's why our arrows are going in that direction. That's why we're starting in that direction. Okay, so when you draw your arrows, you should have them facing the way that my purple ones are facing, because that's the motion that that the point is moving from. Okay, so it's coming from this direction right over here with my blue and green arrow, and continually moving through the function all the way back up. All right, so that's parametric equations. That's graphing them, your x and y coordinates as a function of time, as a function of moving. Okay, so I will have you do example 2 on your own. Okay, so this part you will do in your ed puzzle. So we're not going to do that one together. I want to jump down to eliminating parameters. So when we do that, we're going to solve for t in one of our parameters. Okay, so one of our equations. Okay, we're going to substitute for that t in the second equation, and then we're going to simplify. Okay, so this is what we're going to do. Example 3, we'll do it together so you can see it. So for this one, we're going to solve for t in one of the equations, whichever equation is easier. So pick which one is going to be easy. The one that will be easy to solve for t is my y equals. I'm going to add 1 and move it over. So t equals y plus 1. So then step 2, I'm going to take what t equals here, and I'm going to plug it in for all of my t values in my second equation. So now x equals y plus 1, whole thing squared, minus 3 y plus 1. Okay. Now you're going to expand and do swoop or smiley face or rainbow soda. I don't care what you remember to do. If you remember if it's just foil, you're going to do all of those in this step. You can even distribute your -3 in here. But when all is said and done, you should get your y squared plus 2y plus 1 from your foiling, and then minus 3y minus 3 from distributing your -3. At this point, you combine like terms. So you have your y's that go together, and you've got your 1 and -3 that go together. So I should have y squared minus y minus 2. That is my new equation. I eliminated the parametric, which means I eliminated t. So you're eliminating t. And now we just have x and y's. That's all we have. We have x's and y's. All right. So I'm going to have you do this one on your own. All right. And then I'm going to make a second ed puzzle video for this next part. This is going to be part 2 for 6.2.